ever-evolving world of technology and space exploration, few names stand out as boldly as Elon Musk. Known for revolutionizing industries such as electric vehicles with Tesla and space travel with SpaceX, Musk has consistently pushed the boundaries of what is possible, always seeking ways to bring humanity into the future. One of his most audacious goals, however, lies in the realm of transportation, specifically the development of a hypersonic jet capable of achieving speeds so extraordinary that they approach the speed of light. The idea of a hypersonic jet is not entirely foreign. Throughout the history of aviation, scientists and engineers have experimented with ways to break the sound barrier, fly faster than Mach 1, and eventually achieve Mach 5 and beyond. Hypersonic travel refers to speeds greater than Mach 5, about 3,836 miles per hour, and while there have been various experimental prototypes and concepts, the concept of reaching speeds anywhere close to the speed of light seems a distant dream. However, Musk has never been one to shy away from the impossible, and his ventures into cutting-edge technology show that he is willing to attempt feats that most would consider beyond reach. The dream of reaching the speed of light is rooted in the understanding of physics that we currently have. Specifically, Einstein's theory of relativity. According to relativity, as an object approaches the speed of light, its mass increases, making it harder to accelerate further. Reaching the speed of light itself is said to be impossible under the current laws of physics, as it would require an infinite amount of energy. However, Musk has always shown an ability to think beyond the established paradigms, and many believe that his willingness to challenge the limits of what is thought to be possible could lead to a new breakthrough. A hypersonic jet reaching such speeds would transform the entire landscape of global transportation. For centuries, the challenge of distance and speed has limited human connection and progress. Today, long flights across the world take many hours, and even with advancements in modern jet technology, international travel can be tedious and time-consuming. A hypersonic jet that could approach light speed would revolutionize the way humans move across the globe. What would normally take several hours, such as flying from New York to Tokyo, could be reduced to mere minutes, allowing for unprecedented convenience and connectivity. Musk's vision for the future includes a jet that could drastically reduce travel times, not just between cities, but between countries and continents. This would radically change not only personal travel, but also the transportation of goods. Cargo shipping, which can take weeks to reach its destination, would become almost instantaneous. The impact on global trade, supply chains, and international business could be profound, creating a hyper-connected world where distance no longer poses a significant barrier. In true Musk fashion, his dream is not just about achieving technical feats. It's about reshaping the world. Musk has often spoken about his desire to make life on Earth more sustainable while also preparing humanity for the future, which may include establishing colonies on Mars. His vision for a hypersonic jet is tied to this larger ambition. By unlocking the ability to travel at or near light speed, humanity could potentially extend its reach beyond the confines of Earth and explore the farthest reaches of space. The notion of reaching such speeds, while still theoretical, is a testament to Musk's unparalleled ambition. His projects often seem beyond the grasp of current technology, yet he has proven time and again that with innovation, determination, and the right team, what once seemed impossible can become a reality. While developing a hypersonic jet capable of reaching light speed may seem like an unattainable dream, it is precisely the kind of challenge Musk thrives on. Whether or not this bold vision materializes, it signals that the boundaries of possibility are not set in stone, and that, with perseverance, the future of travel could look very different from what we know today. The idea of a hypersonic jet capable of approaching the speed of light challenges some of the most fundamental laws of physics that govern the universe. At the core of these challenges is the concept of relativistic physics, first proposed by Albert Einstein in the early 20th century. Einstein's theory of relativity suggests that as an object approaches the speed of light, its mass increases exponentially, requiring increasingly greater amounts of energy to continue accelerating. This means that, in theory, achieving light-speed travel would require infinite energy. something that is currently beyond our capabilities and understanding. Despite these scientific limitations, Elon Musk's ambitions with a hypersonic jet are founded on his belief that humanity can push the boundaries of knowledge, defy what's considered impossible, and potentially rewrite the rules of physics. Musk's mindset is rooted in a philosophy that has led him to accomplish the unthinkable with ventures like SpaceX and Tesla. His success in taking on the seemingly unattainable in aerospace and electric vehicles demonstrates his unique ability to not only envision groundbreaking possibilities, but also to assemble the right team of scientists, engineers, and innovators to attempt the impossible. The physics of light speed travel, however, presents significant hurdles. In Einstein's special theory of relativity, as an object with mass approaches the speed of light, the object's energy demand increases. This effect is most dramatically visible in the equation E equals mc squared, which shows that energy and mass are interchangeable. As an object gains speed, its mass increases, and it requires more energy to keep accelerating. To accelerate an object to the speed of light, it would need to attain an infinite amount of energy, which is, by our current understanding, a fundamental barrier. Musk, however, doesn't operate within the constraints of conventional thought. With each of his ventures, from reusable rockets to electric vehicles that challenge the very nature of the automotive industry, Musk has shown that breaking traditional molds can lead to unexpected solutions. In the case of hypersonic flight, Musk is likely looking to reimagine the fundamentals of propulsion and energy. Some speculative theories suggest that reaching near light speeds could involve manipulating space-time, utilizing concepts like the Alcubierre drive or warp drive that could theoretically allow objects to travel faster than light by bending space itself rather than accelerating through it at extreme speeds. While these theories remain highly theoretical, they are examples of the kind of radical thinking Musk is known for. The concept of a warp drive, proposed by physicist Miguel Alcubierre in the 1990s, suggests that instead of an object moving through space, space itself could move around the object, compressing space in front of it and expanding it behind. This would, in theory, allow for faster-than-light travel without violating the laws of relativity, as the object itself would not be moving through space at superluminal speeds. Instead, the space around it would be manipulated. Although this idea is still in the realm of science fiction and has many unresolved issues, the idea of manipulating space-time may hold the key to breaking through the light speed barrier. Even if such speculative methods are out of reach, there are more immediate challenges that Musk's team could focus on. For instance, achieving extreme hypersonic speeds, such as Mach 10 or higher, is still a monumental achievement. Current technologies such as scramjets, supersonic combustion ramjets, and other advanced propulsion systems could serve as stepping stones toward this ambitious goal. To reach hypersonic speeds, propulsion systems need to be far more advanced than those used in conventional jets. Conventional jet engines, which are designed for subsonic and supersonic speeds, simply cannot operate at the extreme altitudes and temperatures involved in hypersonic flight. To reach such speeds, Musk may look into alternative propulsion systems that combine the power of advanced thermodynamics and new propulsion technology. One such area that has been the subject of speculation is the use of nuclear-powered engines, or even antimatter propulsion systems. Nuclear-powered engines are already being used in some space exploration programs, as they offer a much more efficient energy source than traditional chemical propulsion. Antimatter, though still far from practical use, could theoretically provide an immense amount of energy that would be needed to push a craft toward the speed of light. Even if achieving light speed travel remains outside the realm of current science, these types of developments are not entirely out of reach. The path to faster-than-light travel may begin with developing a robust hypersonic jet that can reach the extreme speeds of Mach 10, Mach 20, or even higher. These vehicles would push the boundaries of aviation and aerospace technology to new frontiers, much in the same way that SpaceX has revolutionized rocket technology and Tesla has disrupted the electric vehicle market. The speed of light is an immutable limit in physics, as we currently understand it, However, Elon Musk's approach to innovation has always been about challenging the impossible and rethinking what is possible. Musk has a long history of attempting to achieve what others deem unattainable, often with groundbreaking results. By applying the same level of creativity and determination to the pursuit of hypersonic travel, Musk could potentially lead the world into a new era of transportation that defies everything we once thought was impossible. In this pursuit, Musk's bold vision could inspire new ideas, new technology, and potentially a revolution in how we think about the laws of physics and the universe. While the road to light-speed travel may be long and filled with unimaginable challenges, it is precisely the type of visionary thinking that has driven humanity to push beyond the boundaries of what was once considered impossible. In the pursuit of breaking through the speed of light, Elon Musk may one day succeed in not only defying the laws of physics, but also in transforming how we experience the world. To make Elon Musk's vision of a hypersonic jet that approaches the speed of light a reality, groundbreaking advancements in several key areas of technology would be necessary. While it might seem like an impossible challenge, Musk has consistently demonstrated an ability to disrupt industries and develop technology that most people once thought unattainable. The task of creating a jet capable of traveling at speeds that are almost unimaginable, let alone near light speed, would require a combination of revolutionary propulsion systems, advanced materials, and incredible engineering feats. One of the most critical components of achieving hypersonic flight is developing a propulsion system that can sustain speeds far beyond the capabilities of current engines. Traditional jet engines, even those used in supersonic planes like the Concorde or military jets, are designed to operate within a limited speed range. These engines work by using air to create thrust, but at hypersonic speeds, the physics involved change drastically. Air at such speeds compresses dramatically, creating intense heat and pressure. Existing propulsion methods, like turbojets and ramjets, are not capable of managing the high velocities required to achieve hypersonic travel, let alone light speed. One alternative propulsion system that could be explored is the scramjet, supersonic combustion ramjet, a device that uses supersonic airflow through the engine for combustion. Scramjets have the potential to operate at much higher speeds than traditional jet engines, as they don't rely on rotating parts but instead use air flowing at supersonic speeds to ignite fuel. This concept is already being tested on hypersonic research vehicles, and while there are many hurdles to overcome, it remains one of the most promising avenues for hypersonic flight. However, even with scramjets, it is still a far cry from reaching the speed of light. For true light speed travel, new approaches might be needed that go beyond anything currently in the field of aviation or aerospace engineering. One potential breakthrough in propulsion could involve harnessing nuclear energy. Nuclear propulsion systems have long been considered a possibility for space exploration because of their high energy output and potential efficiency. A nuclear-powered engine could theoretically allow a craft to achieve much higher speeds compared to traditional chemical propulsion systems. However, designing a small, efficient, and safe nuclear engine that can withstand the demands of hypersonic flight would be a monumental task, requiring immense innovation in both safety and energy containment. Another possibility could involve the use of antimatter, one of the most potent sources of energy that humanity currently knows about. When matter and antimatter collide, they annihilate each other and release vast amounts of energy. This form of energy, if harnessed, could be used to power an aircraft at extraordinary speeds. However, antimatter remains mostly theoretical, and producing sufficient amounts of it, let alone storing and using it safely, is far beyond our current capabilities. Yet, if antimatter propulsion were to become a reality, it could unlock the door to interstellar travel, and the pursuit of such technology could be the next step in Musk's vision for a hypersonic jet. Another significant hurdle to overcome in developing a hypersonic jet that could travel at speeds approaching the speed of light is the development of advanced materials that can withstand the intense heat, pressure, and friction generated at such high speeds. Hypersonic flight generates immense temperatures, and as an aircraft accelerates to these extreme velocities, the heat created by friction with the atmosphere could easily melt or destroy conventional materials. Current heat-resistant materials, such as those used in space shuttles, are designed for re-entry into the Earth's atmosphere, but they would not be sufficient for sustained hypersonic flight. To counter this, new materials would need to be developed. Materials with extreme heat tolerance, structural integrity, and flexibility. One possibility could be the use of advanced composites or ceramic matrix composites, which have been used in aerospace applications for years. These materials are lightweight yet incredibly strong and can withstand high temperatures. Additionally, new innovations in graphene and carbon nanotubes might offer new ways to create materials that can handle the immense stress and temperature differentials encountered in hypersonic flight. Furthermore, the energy required to sustain flight at near light speed would be enormous. Currently, energy sources for aviation are limited, with the most common being jet fuel. Musk's jet would need a far more efficient and powerful energy source, well, potentially one that could tap into nuclear fusion or even an entirely new form of energy. Advances in energy storage, such as the development of ultra-efficient batteries or energy-dense fuel cells, would be required to make these technologies feasible. Without access to these advanced energy sources, the enormous demands of hypersonic or near-light-speed travel would be impossible to meet. In addition to propulsion and materials, one of the biggest challenges would be the design of an aircraft that can handle the immense forces and stresses of traveling at such high velocities. At hypersonic speeds, the aerodynamic forces involved would be far greater than anything experienced by modern aircraft. Musk's jet would need to be designed with an incredibly strong yet lightweight structure to withstand these forces. This would likely involve advanced computer modeling and simulations to predict the behavior of the aircraft at extreme speeds and ensure that it can handle the intense heat and pressure. Flight control and navigation systems would also need to be radically rethought for such speeds. At hypersonic velocities, small changes in the flight path could have dramatic consequences, so precision in control and stability would be essential. Musk's jet would need to be equipped with advanced sensors and systems to manage the aerodynamics and ensure safe, smooth flight. Achieving a jet that could travel at speeds near that of light would not just require the development of new technologies, but also new ways of thinking about propulsion, energy, materials, and aerospace engineering. It would take a concerted effort across multiple fields of science and engineering, combining the latest advances in quantum mechanics, materials science, and energy systems. Even if the ultimate goal of achieving light-speed travel remains out of reach for the foreseeable future, the technologies developed along the way could still revolutionize aviation and space exploration. Elon Musk's ability to envision a future that pushes the limits of what is currently possible means that even if light-speed travel proves unachievable, the innovations required to reach such a goal would likely lead to other breakthroughs. These innovations could transform the way we live, travel, and explore the universe, making the impossible seem just a little bit more attainable. The road to hypersonic, light-speed travel may be long, but with Musk at the helm, it's clear that the journey has already begun.